Looking at section 1.2 part A here on simplifying expressions. In part A, we're going to look particularly at the commutative, associative, and distributive laws. First of all, we have two statements that are true using the commutative law, both for multiplication and again for addition. I guess addition's first. So we know that the commutative law for addition states that 3 plus 7 is the same thing as 7 plus 3. You can add in either order. It's also true that 3 times 7 is the same thing as 7 times 3. Those are two examples of the commutative law. So the commutative law for addition and for multiplication says, if I was going to write it in an expression, says that A plus B is equal to B plus A. I can add two things in either order. A times B is equal to B times A. So these laws mean that, order, sorry if that's sloppy there, I was supposed to say order. Order is what doesn't matter in addition or multiplication problems. Of course, it does matter in division and subtraction, but for just adding or just multiplying, order doesn't matter. So we can use the commutative law to rearrange expressions to get them in what we are going to consider the standard form. So in this first one, if I have 5 plus x, I could rewrite that as x plus 5, just switching the order. And in part B, if I have x times 2, I can rewrite that as 2 times x. Order doesn't matter in addition, and order doesn't matter in multiplication based on the commutative law. Now, the way we've rewritten both of these are going to be in our new standard order for expressions. If you have two terms in an expression, you want your variable term first. That's going to be part of the standard order. And if you have one term, one piece, no additions or subtractions between them, you want the coefficient first and the variable second. We're working on some of those definitions throughout the rest of this section. A term is a variable, a constant, or a product of constants and one or more variables, maybe raised to powers. So for example, 2x itself is a single term, like we saw up here in part B. 5 is a single term. X plus 5 is two terms because they're separated by addition. It has to be a product, 2 times x, in order for it to be a term. Other terms might be x squared y. You can have two variables, it can have powers, but what we're not going to see in terms, the definition here is a term, what we're not going to see here in terms is additions and subtractions. You may see negatives, so negative 3 halves x cubed. That's a single term. When an expression contains both constant terms and variable terms, the variable terms are usually written to the left of the constant terms. And that's what we saw in part A up here. If we have both constant terms and variable terms, the variable terms are going to be written on the left, just like that one was. Okay. All right, in example 7, so we're going to take the expression 7 minus 3x, and we're going to rewrite it so that our variable term is to the left of our constant term. So I want the negative 3x to swing out to the front and the 7 to swing to the end. Note that this entire term is negative 3x and this entire term is 7. So that negative belongs with the 3x. So when I reorder it, it's going to be negative 3x plus 7. You don't see the plus in front of the 7, but positive numbers, the plus is invisible in front of them, but you do need to write it if it's going to be non the first term. So that is now, again, back in our common form right here, like we said, we want to write the variable term to the left of the constant term. All right, and our next page, there's a couple other laws here. The next one is the associative law. So first we have a couple equations at the top to kind of verify it to ourselves here. If I'm going to add 3 plus 2 plus 5, first 3 plus 2 is 5, plus 5, that would be 10. On the other side, 3 plus 2 plus 5, so that would be 3 plus, and 2 plus 5 is 7, and 3 plus 7 is 10. So you can verify for yourself that this is a true equation, but the places where the parentheses are different. The numbers are all the same, and their order is all the same. It's the grouping that's different. In the next one, this is a multiplication problem. 3 times 2 is 6 times 5, that's 30. Or 3 times 2 times 5, which is 10, that's also 30. So the grouping, as long as they're in the same order and as long as you have all additions or all multiplications, doesn't matter. This is the associative law. Okay, so the associative law for addition says that a plus b plus c is the same as, you can either add a and b first, or you can add b and c first. It's also true that you could do a and c first. So you could, this would be a combination of both the associative law and the commutative law, which allowed us to switch b and c. So this has to use both laws for this last one. So if I put with commutative here, then then all three of those statements are true. All right, but the first two statements are equal by just the associative law because I didn't change the order. If we throw in the commutative as well, we can get all sorts of orders up there. Okay, the associative law for multiplication, keeping the order the same, I can do a times b first, then multiply by c, or I can do a times the product of b times c. Okay, so these laws mean that grouping, that's the parentheses, doesn't matter in addition or multiplication problems. In example 7, we're going to look at the associative law to rewrite these expressions in another form. So if I have w plus 4 plus 6, the associative law says this is w plus 4 plus 6. Now, I can do 4 plus 6 because those are both numbers. So this is the same as w plus 10. So the associative law is one of the laws that allows us to simplify expressions. It says that I can regroup things in such a way that I can add my numbers together and therefore combine it into a simpler expression. The same is going to work out over here in part B, associative law, again, but this time of multiplication. So I can regroup this one. It's already in this form. I can regroup it back to this form to get the two numbers together. So I can take this to 8 times 4 times x. 8 times 4 is 32, so 32 times x. So I can regroup these using the associative law, effectively multiplying those two values together. Most often we don't show the associative law grouping. We just use that we know that I can multiply those two coefficients together. But it really is a use of the associative law. The associative law is a property that allows us to do that. Cool. All right, and the last law that goes in this grouping here is called the distributive law. And the distributive law starts with, if I look at the problem, 3 times 2 plus 4 and 3 times 2 plus 2 times 4. They're supposed to be equal. Let's check that they are. So this is 3 times 2 plus 4 is 6, and 3 times 6 is 18. On the other side, following order of operations, I'm going to multiply before I add. So 3 times 2 is 6, plus 2 times 4 is 8. And if I add, there is actually a mistake right here. I'm going to fix this. It's going to look better before you get to your notes. This is supposed to be a 3. It should already be a 3 in your notes. Apologize for that. So this is 3 times 4 is 12. There we go. And then 6 plus 12 is 18. Something didn't work out there when I was typing this. So this should have been a 3 right there. Okay. Because of that 3 right there, the associative law, this is the distributive law. The distributive law says that you can take a number, like this 3 right here, that's being multiplied by a sum, and instead you can take the sum of that same number, 3, being multiplied by each of the inner two pieces. Okay. So if I was to write out the distributive law is an expression, it would say that a times b plus c is, sometimes we draw arrows to show our distributing. We would say it's a times b plus a times c. So it's a way of getting the same answer that you get following the initial order operations without doing the parentheses first. Now normally if you had a numeric expression, you would just want to add them up on the inside and multiply together. You get there in a fewer number of steps in most cases. However, if you have variables where you're not allowed to add the two things in the middle, the distributive law gives you a way around that so that you can get rid of your parentheses. So this law means that we can remove parentheses if we multiply the term on the outside by both terms on the inside, or maybe more than both. There could be 3 terms on the inside, so let's qualify that with an all there. Both or all terms on the inside. Okay. Now we have a chance here to use the distributive law. So I have negative 2 times 3 negative 2 times x, and negative 2 times 3. All right, first of all, negative 2 times x is negative 2x, and then negative 2 times 3 is negative 6. That's all I need to do for the distributive law right there. I'm just trying to rewrite this as an equivalent expression by multiplying the coefficient on the outside by both parts of the inside. First part, then second part. All right, and our last piece, we're using the distributive law again. I like to draw my arrows here, or my little arcs, to show both parts of the distribute. I'm going to take 4 times 2x. This is actually going to use the distributive and the associative laws, because when I do 4 times 2x, just like up here, those two numbers are going to multiply with each other, and I'm going to be able to combine that to 8x. And then 4 times negative 8 is negative 32.